Um, so I'm like thinking about squaring, right? Um, so if you square 4, you get 16, right? Um, and so I think this is maybe a theory or maybe it may be a law, it may be something that someone already knows, but I feel like the pattern of something being squared or a number being squared is that you're just adding the two you're adding the two numbers you're adding the number that's being squared to the number that is underneath that. So for example, if I'm squaring uh 13, right? And so if I add those if I and then if I get the lower number, if I get the number uh that is lower than 13, but it's just one under, it's 12. So if I say, well, um if I add those together, I get 15. So if I add 15 um to the square root of 12, I get 69, which is the square root of 13. And I could do that with anything, right? I could do that with anything. So if you're doing a big number, right, like 25. So if I say, well, we know everything, like that's a pretty easy square, right? So 25 times 25 is 625. But if I want if I add 25 to 24, I get 49. And if I subtract 49 from 625, I get 576, which is the square root of 24. And you can do that with anything, right? If you can say, well, that only works with low numbers. No, if you do, I don't know, if you're squaring, let's just say, Jesus, uh, I don't know, like you see the pattern. So what the pattern is is not. I just barely caught that right now, right? If you add the number being squared and the number underneath that being squared together, you you get either, if you subtract that number, you get the number that's underneath that being squared, and if you add those numbers, you get the number that is being squared, right? But it's not, you don't get the number that's being squared, but it's basically what's going on is you're adding two to the beginning of so how would you're adding two from a stage where it's been set by 5. So it starts off by an increment of 5 in the beginning when you square something, right? So for example, 2 times 2 is 4, and 3 times 3 is 9. So the distance between 4 and 9 is 5. So that's the original order, right? So then if you add 2 to 5, you get the next square root. If you add 2 to 7, you get the next square root. If you add 2 to 9, you get the next square root, right? So then, right? So, um, that's what it is. It's you're adding square rooting. When you're square rooting something, you're just basically adding by 2, right? You're adding by 2 to a number that's already that to a number that is already like in existence, and that number is always going to be a negative number. I mean, not negative. I mean, a odd number. You're all you may maybe it changes. No, because if you're if you're adding two to a odd number, it's gonna stay odd. All these numbers that are gonna be um, um, combined is always gonna be odd because the numbers that are being added together, like 16 plus 15 is 31. That's gonna be odd. And if you add 31, so if you want to know what the square root of 16 times 16, I mean 16 times 16, um, that's 30. That's 31, right? So there's a distance of 31, and if you add that to, let's see, how would you do it? So let's see, um, if I know 15 times 15 is 225. So if I add 31 to 225, I get the square root of 16, which is, I believe it, I don't know, I'm just doing it off the top of my head, is like 256. 256. Let's see. Uh, 13 times 13 equals, wait, no, not 13. I said 16 times 16. 16 times 16 is 256. Look at that. You did you like, dude, like you, and so then if I want to know what the square root of 17 is, all I got to do is add 33. um is no is it 33? Cuz is it 33? Yeah, it's 33 cuz 16 plus 17 is 33. So if I add 33 to 256, that gives me the square root of 17 times 17. And so that would be, I think it's 289. Holy crap. But yeah, it starts off by 5. So then if I were to make a formula of something, it would be like it would be it would be n plus 2. It would be like n plus 2. No, it would be n, no, it would be, yeah, it would be, no, it would be 5 plus 2. It would be times n. Not times n. You wouldn't times it. It would be it would be how, because so if that number is constantly changing by 2, would it be n plus 2? How would I do that though? How would I create a formula that basically gives, because well, it how would you create a formula that basically gives you um, a way to solve any square root? Because like the easy ones are going to be easy, right? Like, oh well, 7 times 7, 7 squared is basically 49, right? The lower ones. But then if I say, well, what's the square root of like 4,767? What is the square root of that, right? So there has to be a way where I can say like, um, I think that's what it would be. It would be Okay, like for easy terms, right? So if you want to know what the square root of like five, let's just say like 4,005, right? So then I would say, okay, well, I would say 4,005 minus, no, plus 4,004. If I add those together, um, I would get 8,009. 8,009, and then I would subtract that from. I would subtract that from, and then you would say, well, minus what? What would you? Because if you're adding them together, see, that's what you would have to. How would I do that though? I wouldn't say it wouldn't be minus. So then I would, well, it would be like, because, well, then if I know, if I'm gonna take away, so then would it be, well, maybe this is what it is. If you take a shortcut, and if you're saying, well, for if you know what if you know, it would be what, let me see. Okay, well then maybe this is what it is, right? So if you add the numbers together, and then if you know a short, not the shortcut, but let's see. So if I'm doing 4,005, if I want to know what the square root of 4,005 is, so then I will add 4,005 plus 4,004, which gives me 8,009. So then the square root of 4,005 would be, um, no, because then it would be, because 5 times 5. Yeah, okay. So then I would add that to 16,000. So the square root of 4,005 is 16,800. 809. Let me see that. Let's see if I did that right. That's just calculations off of the head. So 4,005 times 4,005. Oh shoot! I said 4,000. I said 16,000. But then I'm way off though. Look at that. I'm way off. Way off. That doesn't work then. I am super off. I said 16,000. It's 16 million. Did I even? Yeah, 4,005 is 16 million. How was I so off? What the hell? So was it 400? 405 times 405 equals. I knew it was going to be 25 though, because I was like, well, the fives automatically gives you a 5. So how was I off though? Why am I off? So 99 times 99 equals. Oh man, I think I just got proved wrong by my own self. No wonder why. No wonder why it's, bro. Never mind. But I'm that maybe when it gets to the bigger numbers, that thing changes. But I was doing the lower numbers and it was just working. Jesus, maybe when you get to the thousands, it changes by 3 or it changes or something.